you've probably all used a large language model before. Generally, what you do, you give it a prompt, it thinks for a little bit maybe, and then it gives you a response, based on its training material and and how it's constructed, and hopefully the response is related to the prompt and it's what you expect. So an AI agent, really the difference between just a standard LLM approach and an agent is that the agent will take the prompt, it'll think, but then it might also perform an action, and then it might think a bit more and observe those the results of those actions. Then it might loop back and think again. It might do another action. So this is kind of like an iterative cycle before finally giving you a response. And that's basically the end of it. What happens in here, like how that happens, we're going to unpack today. And yeah, there's not just one way to do that. But yeah, I feel like that's an okay definition for what an agent is. And so the idea is that like single agents can do quite a lot. But if you just pump it full of ideas and prompts and everything, I think, especially if you've been using large language models for a while, you may remember when there was short context length, the models can get confused. They can more likely to hallucinate sort of with large context. So you can wrap up each task that you want your agent to do. They can be much more powerful. Okay, good stuff. Any questions so far? Good. Okay, so you may have heard these terms, tools and skills. Generally, an agent has these in their repertoire. A tool is basically a function, often a Python function that does a certain thing. So traditionally, LLMs are pretty bad at mathematics. So if you asked it like, what's 2 + 2, it might pass that to like a calculator or like a Python program that will calculate these things and then return the answer. And so it can do things like that rather than just using, large language model text prediction to try and come up with an answer. So you can imagine already like that's a much more powerful way to get real grounded answers. And so tools can also be things like Google search. So you say, hey, what's the weather like today? An LLM doesn't have that in their training material, but it might be able to do a Google search and go and return something like that. And there's a bunch of tools that already exist in different frameworks. So I mentioned today we're using the Google's agent development kit. The other big ones are sort of this Crew AI and also LangChain. So they're sort of big agent sort of platforms that you might hear about as well. And there's tools that exist in these frameworks that people can kind of give to their agents, or you can just use a normal Python function, as I mentioned. But if I click on some of these, you can see sort of some things that you might use. Different APIs, Atlassian, BigQuery searches, and yes, a lot of these are very developer focused. But yeah, as you create more agents, they'll probably get published. Okay, and then skills. Skills are a slightly, I guess, a different concept. I've written there, skills are an agent's internalized capability. So this is what an agent is kind of like its job almost. And so a skill in some contexts is it's literally might be a markdown file with like a prompt in it. And so it grounds the agent like, oh, everything I do, I have to also do this prompt that's in this file. And that might just be like always use tabs instead of spaces or something like that. So it could be really, really basic like that. Or the skill could also be like, you are a researcher, but you only can search in bioRxiv. You can't use archive to search for papers or anything. You can only use bioRxiv. And you might give it specific instructions, and so anytime someone says find me a paper, it will activate that skill and go and search that. But yeah, we'll unpack that a bit more. What is that link? Oh yeah, and then there's a few ways to define skills as well. And also, yeah, I'm not real strict on this definition that I've provided there, as there's specific things in different development environments. So in like Codex or in Claude Code. There's specific files that you use, or in anti-gravity, there's specific files that you put your skills in. But then in the ADK, you can set those files as well, or you can actually build skills directly into your code. So we'll talk more about that anyway. Okay, cool. So that's a 10,000 foot overview, but we're going to get straight into some demos. So if everyone wants to open up Google Colab, and we can get going from there. Now, I'll be pretty much following these notes along. I might write a little bit differently, but I have them open in another tab, so I'll be typing along, following these. And what we're going to do is basically build a we're going to build a few different agents that sort of do different things. One will be finding research papers. One will be using an API to find recent earthquakes. We'll be looking at we'll be parsing PDF files as well. And then at the end, we're going to string them all together to build like sort of a literature review agent pipeline, which looks something like that. But we'll build up to that. So hopefully it won't be too complex. And yeah, we'll break in about 50 minutes or so for a couple minutes, and then we've got another hour after that. So look out for that. Okay, good stuff. Oh yes, and I've noticed a few questions coming through. Please, post your questions in the chat, and if anyone in the community wants to reply, please do. It's a great way to learn. Or I'll get to it. Will we offer the whole course again soon? It's not on the calendar, but I mean, if there's demand for it, we can definitely do that. And how can we effectively build AI agents to perform real-time web scraping and retrieve those? Good question. We will hopefully see that in action today. So let's do that. Okay, I'm going to open up Google Colab. Going to click that yet? Let's see. Okay, I'm just going to click Start a New Notebook. Go down here, and I'll adjust my screen real estate so everyone can see okay. Let's see, I might just... Okay, so yours probably looks something like this. You can give this give it a name if you want. Agents demo workshop. So it's saved automatically in your Google Drive. And the first line of code we're going to write is we'll just install this PyPDF. So this is just for manipulating PDF files. Everything else should already be pre-installed in the default Google Colab environment. If you come back in 12 months, versions would have changed. So you may have to install things. But for now, I think these versions are installed by default, so we don't have to do anything. But if you're working in your own environment as well, you might have to install stuff too. So I'm just going to use the pip installer. So ! pip install PyPDF. And I'll run that, and that should install this PyPDF package, which we'll use in a bit to scrape some PDFs. Yes, the recordings of these will be posted on our YouTube page and on the GDG for Science pages as well. Cool. So that's installed, and I'm just going to hide my header visibility. And so we'll get some screen real estate. Cool. And then the next thing we need to do, this is a little bit tricky. We're going to get an API key from Google's AI Studio, and we're going to use the AI Studio to basically connect to Gemini models in the cloud, or whatever models we want. You can there's several ways to kind of like set this up, so then everything else below it then will connect to whatever model provider that you're using. One of them is using the AI Studio. I think like OpenAI API keys work here as well. So I think that just works out of the box. You can also connect directly to like your Google Cloud instance, which uses like a different pool of resources. That's a little bit more involved. Not too much. It just requires like a little bit more setup. But then the code below is also like the same as well. But we'll use AI Studio today. So I'll click on that link. I'll post it in the chat. Okay, so that's automatically taken me to my API page. If you haven't used AI Studio before, it's a place where you can kind of like quickly test out AI agents in code and play around with different models and not fine tune, adjust their parameters and everything. And we'll come back here and look at our dashboard later to see how many resources we're using. So yeah, you can see how many times I've been using it, and we'll try not to hit our rate limits today, but if we do, that's not so bad. Okay, so I need an API key. So I'm going to click Create API Key. I'll pick a project. What's my cool project? Maybe that one. Okay, we'll call it Gemini API Key. Create key. I think that's good stuff. So yeah, I've mentioned before, never share this API key. I'm going to delete this API key at the end of this session. But yeah, it's basically a password to my AI Studio. I'm operating the free tier though, so worst case scenario, you'll just hit the rate limits and it will tell you as such. Okay, so I now have that key copied. There's a few ways to sort of get it into your environment here. In the notes, I actually use like the Colab secret manager, and so I've got a couple there. I can add a secret and call it and paste my API key in there, and then I extract it from there, and that's a good way to kind of manage things. But for today, I can just basically say import OS. So that's going to be that's a standard Python package, which lets us do operating system level interactions. And I'm going to do os.environ, and I'm going to set a variable called Google API key, and I'm going to say equals, and then I'm going to paste my key there. Okay, so that's it. And then if I run that, it should now be in my environment. Hopefully that will work. We'll see in a minute if it fails or not. Okay, is everyone okay at this point? That's sort of a big sticking point. From here, we just step through the code. But once that's set up, hopefully it will work. We'll see when we make our first request whether it worked or not. Okay, next we are going to now up front. We're going to import all these tools that we need. I'll talk through them as I import them. You can copy and paste them, but I'll just type them out. So importing requests, that's a standard Python package for doing like API calls to external services. IO for opening files. I'm importing PDF, which was the PDF parser that we're going to use that we installed earlier. And now here's the fun ones from google.adk.agents. I'm going to import agent. This is the main driver of our agents. It's this class, this object in Python, which has all these large language model knowledge and rules around it, and we'll see how that works soon. From google.adk.tools, I'm going to import Google_search. So that's one of those built-in tools that our agent will use. From google.adk.runners. Now I'll talk about this soon, but the runner is basically a way for the agent to kind of work asynchronously and connect between the model provider and your code and see when that result is created. So it runs back and forth between it. I guess you can talk about that. You can think of it that way. Okay, google.adk.sessions. This is how we this is a way memory session service and session. Okay, good. So they will be how we store the knowledge of the large language model somewhere. So we need to store it somewhere. Otherwise, when you ask a follow-up question, it won't know where it is. So that's what that will do. From google.adk.tools again, we're going to import agent tool. So that one is more generic tools. So when we create our own, and from Google import GenAI. That's the standard GenAI package, which lets us interact with Google large language models, not the ADK, so you can use them separately. And then from that as well, we need Google from google.genai.types. So I'll make you type this out by hand because it enforces muscle memory and makes you learn it. Content. So I mean like that. Okay, and then we also bring in these types, which are you can think of the types as a like a list or a string or a float or something, but they're particular parts of the large language model when it returns certain data. They're types of that come back from that. Okay, I'll run that. Hopefully no errors. Great. So that ran. And everything imported as expected, but we'll see as we keep going. Okay, so we're going to now define our first agent, and yeah, this is a really fun bit. So I'm going to call this the lit review agent, and there's that agent class that we imported. So this is a type agent. We can go and read the docs on what this agent does. And we have to give it a name. So name equals, I think standard practice is to give it the same name as your Python variable, something informative. So that's a required. The model, so we give it a model name. Now okay, we're using Gemini 2.5-Flash-Lite. That is, you need to know these like exact model names, and they are in the AI Studio sort of notes. I've just realized they've changed the icon there. Very nice. Okay, so if you go to the dashboard and playground and models, I think right here. Oh yeah, so here you can select your model, and you can search through the models, and it has the actual name that you'll need. So Gemini Flash latest, Gemini Flash-Lite-latest, Gemini 2.5-Flash. So that's where you can get those model names for what's available in AI Studio. And as I mentioned, if you use Google Cloud Platform, you can get access to a bunch more models as well. So they're just the ones that are available here. You can even roll your own models and host them. Okay, cool. So they're required. We need to give it a description. I think this is required. So this is for the models, the language models, and other agents to know what this agent does. So it will read. If you say like, "Hey, go find me some papers," it will be like, "Hey, I need an agent that has a skill that has that capability," and it will just read the description before it reads like or anything else. So this is important for the agent to know. Assistant that finds recent scientific articles. Very good. Okay, and then the instruction. This is your standard prompt. So I'm going to do 3 quotation marks, so it's a multi-line quote. And I say, "You are a helpful researcher. Your job is to find scientific," I'll go to a new line, "articles on the topic asked for, please return, please use the Google search tool to search archive.org only, find 5 results on the topic, and present the results in a clear numbered list. Okay, so I've been a bit more loose, I guess, with my prompt there than what's in the notes. Hopefully that works just as well, but we'll see. Okay, I think that's actually all that's kind of required in an agent. Like, it's just a prompt, and you've given an instruction, and so that's everything. But for this one, we're going to give it a tool, and we're also going to capture the output of that this agent in this output underscore key, and we can call that whatever we like, but we'll call it our research papers. So that way, when we pass the result of this to something else, we can just say read research paper, research underscore papers, and go from there. Okay, and the tools it's going to be using in this case is that function that we imported before, Google underscore search. So we imported that earlier, and that's literally the ADK provided Google search tool. Okay, great. So let me run that. Success, very good. I can just check it. .name, it has all these attributes, the review agent, so that's what it looks like. Basically all the options, and some we've set some of the defaults, and so we can work with that. Okay, great. So what's going to happen when we prompt this, find recent papers? The lit review agent will it contacts that agent, and we're told to use the Google search tool to go and find search for archive.org results and return some paper IDs, and then we'll make that search, get them back, and synthesize the findings before giving us an output. So hopefully that's what's going to happen in this agent. Now, to actually run everything, we need to kind of set up this framework, and there's a few parts to it. Basically, I mentioned we need the session service. This object manages the agent's memory, so we'll use something that just keeps it in our RAM, but there's different sort of services. So you can use like cloud services if it's like a really big thing, or you can you can use a file instead of RAM. There's different sort of options for that. We have this concept of a runner, so that object connects the agent and the memory, and your input to make everything work. So when you normally program, you go from top to bottom and you execute one line after the other. But because the agent's kind of going back and forth between the memory, the model provider, the model output, your instructions to the model, it needs to sort of work asynchronously and do a few things. So the runner takes care of that. Now, there's also this async and await syntax, which we're going to see. And I find, if you're new to this sort of program, if you haven't done any sort of web development or anything JavaScript, and you've just used Python to write scripts, it can be somewhat confusing. But basically, all we're saying is that, like, while one thing happens, we have to allow other things to happen too. We can't just wait for the previous instruction to end. And there's just a certain structure that we have to set up for that to work properly. And because we're working in a Google Colab specifically, they're kind of wrapped in these big asynchronous environments, because we're on the web, we're putting text in, sometimes we get stuff back, sometimes it waits for mouse clicks. So that can be a bit confusing too. So this is a little bit different from what you might see in the documentation. However, at the end of the this section, I also have like the what would happen if you ran this not in a Colab environment, just in your local machine. It's just slightly different where we put these await, and I think, is there an async one? Maybe we don't need the async one. Yeah, we need the async one when you're running it outside a Google Colab environment. Okay, good. So if there's questions, feel free to ask. Otherwise, we can just write it up. Oh yeah, question. Thanks, Thomas. How can we leverage Gemini's long context window on Google Cloud to build an autonomous research, to build an autonomous that compares historical data with trends? That's a big question. Could build an autonomous research that compares historical data with trends. We'll look at, yeah, hopefully by the end of this, you can kind of do that. In the anti-gravity session next week, we'll kind of do a bit more things closer aligned to that, I think. Okay, let's set our session underscore service, and we'll call it in-memory session service with parentheses. Good stuff. So that creates that memory service, and we're going to use this session service object there, and we're going to create a runner. So agent runner equals runner, and then we give it a few options in there. We go agent equals the lit review agent. So that's the one we just built before. We give it the session service, which equals the session with two S's, session service that we just instantiated a second ago as well. So there's our agent, our session service, and the app name. So the app name, it can be called something different, but I think good practice is to call it the name of your agent. Probably use cases where that wouldn't be the case. Okay, cool. So that's our runner. And we also need a user ID. You can imagine, yeah, in a complex environment where you're deploying this, you might have multiple people using the same thing, so you might have to assign different users. I think for most of our use cases, it's always going to be just one person, just you. But we can call it, let's call it user one, and the session ID. This one you might fall into. You could imagine you have multiple sessions with the one user. So in one, you're talking about literature reviews. In another, you're talking about processing API and processing data or something. So that's why we need to keep track of it there. Okay, user one, session one, and then I create the session by saying session await session underscore service, which is this memory dot create session. Give it the app name as before, so lit underscore review underscore agent dot name. The user ID equals the user ID that we set before, and the session ID equals the session ID that I set before. Good. Okay. Okay. I think that's correct. I'll run that. I got a tick, so that's good. I think that ran. Let me know if you're having issues. Let me just try and also turn off my AI assistance editor. Show context powered code completion. Let's turn off those. Enter key accept suggestions. Cool. Okay. Maybe I won't get so many pop-ups now. Good. So that's that. Okay, we kind of set things up. Now, what do we need to do? We need to come up with a query. So we call it user query. So this is what we ask the agent to do. We can say find papers about recent earthquakes. Good. And okay, now the next thing, now we're going to launch the agent in this next step. And I'm going to save it into a variable called response generator. And I'm going to call it agent underscore runner dot run. So the agent runner we created here, and this is, so the agent runner that we've created, we execute the dot run command, and that will actually like invokes the agent and sets it to work. So this is where it actually starts working. Again, we have to pass the user ID. We pass the session ID. Session ID equals session ID. And then the new message equals, so content. So this is a bit tricky. Parts equals part text equals user query. There may be an updated way to do this. And the role is user. Okay, so I think that's right, and then that's it. So let me just talk about that. So what we're doing, all we're doing is passing this sentence. So we're sending that to our agent runner. We just have to get it in the right format. So you use this content and part sort of function to get our user query in the right tokenized format. And we apply the role of a user. So you might set a different role. So there's options there as opposed to like a system role, or maybe there's other roles as well. And you can see how we've set these sessions and runners up, but we might have multiple different user IDs. So we might have different users coming in at different points, and we might have different sessions as well. So we might have 2 sessions going. Generally, I think for our workflows, again, probably only do that once. Okay, let me run that. Hopefully it works. Now I have this thing. So it's returned a generator, which a Python generator is I guess kind of like a function that spits out content on demand. And to capture that into something that we can I guess work a bit cleanly with, I just have created this list here, all content objects equals, I create an empty list, and then I go for content underscore obj in response generator. So I'm going to loop through what's in here and grab everything. So that was really quick. I think it's executed this already, or maybe it only executes it when I run this. Let's find out. I forget. Or content objects dot append content underscore obj. Okay, I think that's right. Okay, let's run that. Oh yeah, so now it's likely it's doing all the LLM parts, because that took longer. And I can just print out what happened. Let's see if it worked. Super. So hopefully your output looks something like this. Okay, so what it's returned is kind of like everything. It's got the event. So it gives me some details about this event that occurred, which was using model version, Gemini 2.5 Flashlight. It has the content of that is the response of the large language model. So here are some recent scientific articles on earthquakes from archive. And it's given me these, and it hasn't, I told it to give me, I think I told it to give me, oh yeah, 5 results. Yep, okay, no, that's right. So it's giving me 5 results on these different, all these different papers. Hopefully, it hasn't given me like a link or anything, which is not ideal. Although it has given me the links down here. Now, if I click on that, what happens? Does it give me anything? Oh yeah, so cool. So it actually gave me the links back as well. So that was the response of the LLM, but in order to get to that, the agent went and found these different web addresses. Now, the address itself is not there, but there's like a temporary Vertex AI search link, which resolves to the archive paper, which is super cool. So it's working. Higher magnitude earthquake identification using anomaly detection. Great. So it's doing that, and it's telling me what else in there. Is anything else interesting? These sort of snippets that it's come up with. I think it actually returns at some point probably like the entire website here. So the entire website might have like weird, web HTML and CSS. So sometimes like there's far more information in this whole thing than we need. It actually searched multiple, made web search queries. So the Google tool, recent earthquakes archive, earthquake detection archive, so on. So it looked for those. Tells me how many tokens that it used during these searches. All right, so that's the full output, which is cool. And yeah, if we just want the actual content, we can print that out now. And in the notes I have for content obj in all content objects. I just say print content obj dot content dot parts. So yeah, all right, good. So there's the actual bits, I guess, that are most interesting, but there's a lot more information sort of behind the scenes. Okay, great. So you built your first agent. Ben Richardson, I can see you have a typo. Model/Gemini 2.5.flash.lit. It should be flash-light. So that's the typo that you have. Okay, and good stuff. Yeah. So well done if you've managed to do that. You built your first agent. From there, you can take over the world. So that little framework here, this setting this up, the session service, the response generator, like that's it. That's sort of the hardest part. And once you have that, you can tweak your prompts, you can build out your tools, and go from there. And then, okay, yeah, from there, as I mentioned, because we had that session, we can ask it other things as well. Query to see, that is a good start. Refine your results to papers that mention subduction. So that's where one plate goes under the other. And that can often be the cause of earthquakes. And then I can create a new response turn 2 equals agent underscore runner. So I don't have to set everything up again. I just set up another runner. And I do the same thing. So user ID equals user ID, session ID. Importantly, I use the same session. I could use a new session and it would have no idea what I'm talking about. It'd be like, you haven't asked anything before. And then again, new message equals content parts equals, make sure I go do this right, parts, square bracket part text equals query underscore 2, and the role again is the user. Good. And then I can for content obj. So yeah, the generator basically, when it hasn't done anything, we created this generator, and then when we call the generator, it spits out the different parts of it, and actually performs the the calls. In response, turn to. Yes, is there a question? Feel free to unmute yourself or post in the chat. Content. Append. Content. Obj. I'm doing exactly the same thing again. So that's appending it to that original list. You could make a new one, I think. What makes more sense here? Maybe, yeah, I'll keep it the same. Okay, so let's let's run that, and then on the next line, while that's thinking, I can write for content obj in or content objects print content obj dot content dot parts. Let's see. Okay, so there's the scientific articles, and then there's ones that mention subduction. So it's gone back again. It knows the context about earthquakes. I guess the implication there was maybe to take those and only pick from those ones that mention subduction. But yeah, I guess that's a prompting issue, because it's gone back and probably researched everything and like redone the search to find papers that are to do with subduction instead of just general earthquakes. But it's still, yeah, the point is that it has remembered what we've asked it and gone back and forth. Okay, good. After this code block, can you please repeat what's the print code? Oh, yes. So this print code here. So after you create the agent runner and then run this, you run through this generator object which we've created. It then appends the response, the back and forth between the LLM and your code, and appends everything to a list that we can sort of interact with a bit more in an investigatory way instead of just generating the parts that we need. And yep, the results may vary. I think when you set up your model, there's parameters where you can adjust like the temperature and those kinds of parameters where you can make it so the LLM will give you the same response or closer to the same response. But yep, the responses may vary. Okay, cool. So that's a tool. Now we can go and basically we can write our own tool. So this could be a simple function. This example tool I have in the notes, it is used to get earthquakes from the USGS. So they have an API, application programming interface, which basically lets you connect to the USGS and find recent earthquakes, and it will. So you send it a query, and it will come back saying, giving you some options. So the query, it will come back with some results. And the options we can give it are like the latitude, the longitude, so where on the Earth this is, what kind of search radius within that latitude and longitude point, and then a time frame as well. So when have earthquakes appeared in this location during that time frame? So we get our agent to use those parameters, and also the minimum magnitude, so how big the earthquake is. And they will all be optional, and otherwise it'll just use the default parameters. So when you write a function, it's important to give your function a description. So write comments at the top of the function, and so your model, so your agent knows what it does basically, because it will read that and be like, oh yeah, this is the tool that I have to use. It's called get earthquakes, but what does it actually do? And so like the more descriptive or the more accurate you can write this function header, the better, I guess, your agent will perform. And so this calls USGS Earthquake API to find earthquakes in a specific place and time frame. And then it tells the agent what the argument's in. So even though they're defined up here, like you tell it in plain text what it does and what format it's expected. And then what it returns. So it returns a dictionary in GeoJSON format. Okay, and then here's the code for the function. So that's all just the header and setting up the function. So we have a print statement there. So hopefully anytime that function gets used, it should print to our screen. You don't have to include that. And then it uses this base URL to connect to the USGS. It passes all those parameters that we give to it. And it basically just checks, makes sure the earthquakes are within the magnitude limit, and prints out another thing saying where exactly what it's doing, so what the search query will be. And finally, it uses this requests package to make the API request. So it uses Python's request package, which is pretty standard to connect to a remote server. And so we give it that string, and it gives us back some answers. Okay, cool. So I'm just going to copy this, and I'll paste it in the next code block. I'll define it, and then I can call it with, so it's just a function, so I can just call it, and it will use my default parameters. Get what's it called? Get earthquakes, not get functions. Get earthquakes. Earthquakes. So get functions not defined. Get earthquakes should be defined. Cool. So tool called get earthquakes, and it's said what parameters we used. I haven't passed it any, but I can. And so it's querying the API. So it's querying this URL link. So if I go there, you can see, you can actually see the answer in plain text if you like. So it looks like that when I search for it. Very good. And remember, there's nothing agentic here. This is all just standard Python code, I guess. Oh yes, so that's the answer that was returned. So tool returning, and this is what it returns. Cool. But now we can give that tool to our agent, and we can say, hey, what are the newest earthquakes? And it will know to use this tool. Okay, rather than just sort of hallucinating or searching for news articles or doing something like that, it will actually use this tool to go and find us, measured earthquakes. Okay, good stuff. So how are we doing for time? We'll set this one up. It's very much like the other one. We set up the earthquake agent. It's called earthquake agent. We use agent. We said to give it a name, give it a model, give it a description, give it an instruction. And so I'm just going to copy that one, paste it in. And the key difference here, so I've given it name, model, description, instruction. And so the instruction is probably fairly important to get right. You remember the description, the agent reads. So that's very important for the agent to understand what this tool does, a seismology assistant that reports on earthquakes. And then the instruction that we give it once it decides to use it is, you are a helpful seismology assistant. Your job is to report earthquake using the USGS earthquake tool. When a user asks about earthquakes, you must extract user-provided details about time, location, and magnitude if provided. Otherwise, make assumptions based on the user's query or use the function defaults. Use the get earthquakes tool to retrieve USGS reported earthquakes with the inferred input parameters. Report the list of earthquakes you find. If no earthquakes are found, report that clearly. And then the output key is earthquakes. So if we want to use the output of that, we can use this output key. And we'll see how this works later when we're passing information between agents. And the tool, we simply pass it the function name. So that's the only difference between using the Google search agent. Okay, good. Let me execute that. Created. And we set this up exactly the same before, so I'm going to copy and paste. Maybe I should get you to write. No, we can just copy and paste. Basically, it's exactly the same as before. So the session service, the in-memory session service, the agent runner, we set the runner, we set the agent, we set the session service, we set the name, we run a wait, give it name, user ID, session ID. Fantastic. You have to do that every time you create or want to interact with a new session, I guess, a new paradigm. Okay, and then the fun part there, we make a query again, find large earthquakes. Maybe I'll change that. But the response generator is exactly the same as before. We pass the user query. We create this content objects thing. We run the generator, so it's exactly the same as before. There's nothing new there. So let's say around Tonga, we can do Tonga in, let's update to 2026. Find large earthquakes around Tonga in 2026. Okay, and I'll run that. And you can see that the tool is called. So I didn't tell it to, I didn't tell it to use the tool. I just said find large earthquakes around Tonga. And then in the prompt, it knew that it had to use that tool. It determined the latitude and longitude and a search parameters on its own. It also used updated the dates. So 2026, it has looked the dates, and I said large earthquakes, so it's looked for bigger than magnitude 6, which is relatively large. So it's made all those decisions on its own based on the context, find large earthquakes, which is cool. And then we can get the results like we did before, where all content objects _2. And if I just print all that out, oh, did I define it? All content objects, all content objects. I made a typo, objects _2. Yeah, you can see what it's found here. So again, you can read through all the meatiness of it and what it's, or you can just print out like what's in the notes and drill down through this to get out the key bits of information that we want. But yes, so it's found 7.5, 158 kilometers west of Neufu in Tonga on the 24th of the 5th. And it even gives us the event page, so we can go and look at that, which is cool. There we go. So there's an earthquake that occurred around Tonga. So there's the island of Neufu, there's Tonga, and zoom out and get some regional context for where that occurred and the date, which is super interesting. There you go. So I picked Tonga. Tonga is a pretty active area for earthquakes, so there's probably going to be data. You pick Sydney or something, there's not as many earthquakes. Good. Any questions? Oh, it's Thomas. You exceeded your current quota. Please check your plan and billing details for more information on this error. Okay. Yeah. So you can. We can talk about rate limits now. So in the settings, wait, dashboard rate limits. Yeah, you can sort of see, if I pick, what am I doing? I'm doing my cool project. You could, I think, create a new project that might give you some more rate limits, but you can see the basically how many requests per minute and how many are allowed. So Gemini 3 Flash, this is all in the free plan. You get 5 per minute, and how many tokens. So you can do like really, I guess, you can only do 5 requests in a minute, and then it also has requests per day. So the request per day is probably what you've hit, and depending on the model as well. So you could change models. So Flashlight has up to 500 3.1 Flashlight, so you might want to use that one instead of one of these other models. And then if you go to the paid tier, you obviously get significantly more. And I've measured, I think, to run this whole thing from start to finish, it's about 20 cents worth of LLM calls, to give you some context. Okay, cool. So we're up to, we'll have a 5-minute break now. And when we come back, we'll look at dealing with unstructured text. So PDFs and things like that. So we'll build another agent, and then we'll stitch all these together in one literature review master agent. All right, so I'll see you back here in 5 minutes. Feel free to post any questions in the tricky questions coming from Prajita. The answer to this one is easy though. Read the response and check it. There you go. I think that's the only way. Or you can get another agent to review it. Okay, are there any questions that I've missed? They're coming through fairly thick and fast, so please ask them again. Alrighty, so we now have an agent that does an agent that searches for papers. It's a generic agent, so we give it a topic. We say, hey, please find a topic on earthquakes, find a topic on bacteria, find a topic on trees. It will go and find that topic. We then have an agent that specifically uses this tool. So anytime someone mentions earthquakes, so like, hey, I think there was an earthquake, it'll be like, oh, cool, I'll go check for earthquakes and try and give you a response. But it will only invoke that if you call that agent and if you've mentioned an earthquake. If you haven't mentioned an earthquake, it might not do anything. Okay, but yeah, we always pass it like a query which kicks it off. So that's when we pass it the query, and so we'll dive deeper into this when we build a team of agents where we don't necessarily pass queries to. But we're gonna build one more here. So this is an agent that is going to process unstructured data, so text from PDFs. Now, we've come a long way in the last couple of years. This used to be a great reason to use a large language model to parse a PDF, because they come in different formats and everything, and sometimes columns, sometimes they have pictures in them. So an LLM being able to read through an entire PDF and then tell you what the important parts here is quite powerful. I think there's better tools for it, but we can still use sort of this bare bones ones, which just extracts text from the PDF and passes it to the LLM, and it will, what's this one going to do? Let's read it. So again, this is the Python tool. Grabs the raw PDF, so it actually downloads a PDF from a web page. We don't part. This tool doesn't parse it. The agent does that. So this get text from PDF. So we have to give it a URL, specifically an archive URL. I think it might work with other ones actually. Actually, it probably will work with any URL, but archive. I guess it's been written for that. So it extracts all its text and returns the text. So that's it. We give it a URL like this, and it goes and searches that URL, and it will then convert the PDF into text. So that's useful for lots of different things, and in our case, it will be useful to give to the agent. All right, and then we also define our agent. So this is called the detail extractor agent, and it's an assistant that reads research papers. And we're using Gemini 3 Flash Preview. So I've used a couple of different models throughout this whole workshop. Part of that was to avoid the rate limits, but also to give an idea, like using Pro for every request will be expensive and unnecessary. So Flash is like substantially cheaper, and there's Flash Lite as well, which is again significantly cheaper in terms of raw costs and availability. And so if you use the right model for the right tool, it can be much more efficient. I think there was a question in there as well. Can you get some science swag? Yes, probably can. Send me your address, and I'll see if I can get you some swag. I think you've come to every event so far. All right, so this one, we give it the instruction. You're an expert research assistant specializing in passing text from scientific PDFs about geoscience. So we're making this one pretty specific. And oh yeah, we're saying your job is to extract key locations mentioned in the papers related to earthquakes. So that's pretty, like, that would be hard to do, I guess, programmatically. Traditionally, you read a PDF and finding specific locations that talks about earthquakes, I think is a difficult thing to do. Yeah, I can't think of how you'd structure that. Maybe you could do it, but an LLM should get it probably more correct than any other programmatic way to do it. So when a user gives a URL, you must call this get text from PDF, grab the get the PDF's raw text content, so that uses that tool to get the PDF's raw content, and then it actually does just LLM capabilities. It scans the text from the tool, finds the text that corresponds to locations, and returns a date and location of any earthquakes found. So that's the job that it's supposed to do. And if you cannot find any mentioned locations, state clearly and do not make one up. If the tool returns an error, report that error to the user. And so another question about, like, when do you trust a human? So that's one of the beauty of agents as well, because you kind of make it very modular, the workflow, you can see exactly where it's broken down. If you do one monolithic large language model call, you don't really know where the problem is. Whereas if you break it up into agents, you can see, oh yeah, this didn't collect the right response. I was expecting earthquake locations and it found something else. Okay, and yeah, so this, I've bundled everything, the function definition, the model, the agent definition, and also the session service and the runner setup into one large code block. So I can just copy that, paste it in. Oh, my runtime is disconnected after that break and me talking for a long time. So it's going to work. Oh yeah, no, sorry, it didn't disconnect, I think. Yeah, okay, good. So it still worked. You might just have to rerun the first couple of cells if it did. But hopefully, okay, cool. So let me just, I'm going to run this tool, get text from PDF, just to show, what it does. What happens if I don't pass it anything? Oh yeah, it says it's missing one required positional argument, a URL, and I have an example there. Where's my example? This one, my paper URL is that. So let's pass it this URL. Oops. Okay. Okay, so again, that's just text, like that's just a Python command. It's not an agent, but I pass it a URL, and this is just some example one that I've got. So it's earthquake impact analysis based on text mining and social media and analytics. Very good. So that's a paper. Okay, good. So that works. And now we can write exactly the same as we sort of did before. Can you please find any earthquakes mentioned in this research paper at this URL? So just think about how this is working. We are calling this agent, which just takes free text in, like, hello, how are you? What do you want to talk about today? And but it has a particular job. The job is to read PDFs and use this tool. So if it uses that tool, it needs a URL somewhere in the context. I'm curious to know, what happens if I don't give it a URL? It might just freak out. And what happens if you use a URL wrong? Maybe I'll do that just for fun. You can just copy and run it. I will just say this, and we'll see what response it gives back. Can you find any earthquakes? So please find any earthquakes. Cool. So it's not using this paper URL. What's it going to do? Wait for it to fail. All right, we'll see what the answer looks like. So I can just print out this response here. And it tells me, please provide the URL of the scientific paper you would like me to analyze for earthquake. I'll then use my tools. So that's it. It said like, hey, you haven't given me enough information. Fantastic result. All right, so let me fix that back up. Give me my paper URL using, please find any earthquakes mentioned in this guy paper URL. All right, and I run it again. Oh, what's happened? 503 unavailable. This model is currently experiencing high demand. Okay, I think maybe we're all smashing. Which model did we use? We're using the Gemini 3 Flash Preview. Maybe we could try a different model. Let me just try it again. I think it's working this time. Good. Cool. It looks like it used that PDF, the get text from archive on that particular URL that I passed it. Extracted the PDF, and now it's hopefully thinking about it. Any other questions? When dealing with complex logical reasoning like breakthroughs in physics or deep tech, do you recommend using chain of thought prompting, or should the agent use a tree of thoughts? I don't actually know what a tree of thought is. I don't know. If anyone knows the answer to that, feel free to do it. Okay, what's going on here? It seems like it's calling it a few times. Not sure why it did that. But let's see what it's printed out this time. It may not have used it 3 times. It may, just because of the asynchronous environment, sometimes like things will print to the screen, but then they're still running kind of in the background and something else prints to the screen. So it can be a little bit confusing. Okay, so where's the actual content? So that's the output of the paper, I think. Do I have the code? Oh yeah, this is the code, which will give me the just the bits that I'm interested in. So let's see if I want to print everything. Sorry, I'm scrolling a lot around. I'll try and slow down a bit. Oops. So all content objects, that's this whole thing. I want the last position. So if there's multiple prompts, this will give me the most recent prompt. Give me the content of that and give me parts 0 and just give me the text. That's what that's saying. Based on the research paper provided, the following earthquakes are mentioned: Wenchuan earthquake, China, Haiti earthquake, in Haiti, Yushu earthquake. Very good. So there's quite a few mentioned in there, and it giving me a date and a location. Fantastic. Now you can see maybe where we're going with this. We might be able to link it back to our other tool and say, oh yeah, read this, find papers, read this. Now give me the actual stats about that earthquake. And that is, I believe, what we're going to do in this very next section. So any other questions at the moment? So we're going to build a multi-agent team. So we give it an initial prompt. The agent that gets the prompt will then think about what to do with that prompt. And in its skills, or in its tool repertoire, it will actually have agents as its tools. So in its agent tool, it will have a literature review agent, it will have a detail extractor agent, and it will have our earthquake agent. So I'll have these 3 agents which can call as it needs. And then each of those, we've seen how they work. One does Google searches for archive PDFs. One grabs PDFs and actually reads it. And then another one finds earthquake locations and finds details about them. And then it's going to go back and synthesize the results. Okay, so for this one, I will, in fact, let's type this one out. So we need to define a tools list, which is going to be, I'm going to open these brackets, and we define agent tool. We imported this this at the start, the agent tool, and this turns an agent into a tool that an agent can use. And we have our names for it: lit review agent. and then agent tool. So basically, agent equals our detail extractor agent, and then agent tool agent, our earthquake agent. So we've written 3 agents with different tools and capabilities and skills. All right, so this tool list, we will pass to our new one. And then we make this master agent. So we can call it the reporting agent. And again, it's just an agent like what we've built so far. And the name of it is going to be the earthquake report agent. The model is going to be Gemini 2.5 Flash. And the description is going to be writes comprehensive reports on earthquakes by coordinating research. Good. And then the instruction. Okay, so now this agent is going to, as we'll see, it's going to use those descriptions we've written for those 3 other ones. I don't think this description will ever be read by any other agent, but still good practice in case you wanted to build sub-agents and further sub-agents. All right, so the instructions. Maybe I'll copy this because it's quite dense. But basically, you're the chief seismological reporter. Your goal is to write a comprehensive report on specific earthquake topics requested by the user. To write this report, you must coordinate your team of agents available as tools. So it's good to mention, I think that's still best practice. You have to sort of mention, hey, you've got that tool, use it. And so there's got the literature search. First use the lit review agent, and that's enclosed in what are called backticks. That's the number, the character next to your 1 on your keyboard. I guess good practice, that's like code. The LLMs know Markdown and can recognize that's a piece of code as opposed to just free text. So it probably helps a little bit. To find archive.org identifiers, use recent papers on the topic. So remember, that one's going to send, it will have to ask a question of that agent. So it will say like, hey, find me topics on something. Next will be the paper download. So this one, remember, this one we have to go, hey, here's a URL. Use this to find me information about that. And then for the earthquake data agent, we have to say, here's a location and maybe a date of recent earthquakes. And then finally, so hopefully we'll use three tools there. The synthesis is to combine the findings into a real-time single report. And that will be this agent sort of acting on its own. And for the tools, you pass the tool list. Okay, so I was just here to copy instruction. So good. Okay, so that's the instruction, comma, and then the tools we're going to give are the tools list. Good. This one I haven't given it an output key because I don't think I'm going to use the output of this for anything. Do I use the output keys? Maybe I don't use them yet. I definitely use them. There's another example where I do. So yeah, okay, that's fine. All right, so tools, tool list, that's that thing we just defined. Let me run that. Good, it worked. And we can say the user query equals something like earthquakes in Tonga, earthquakes in, or we can pick a different place, Indonesia. Go. And so that's the query that we're going to send. That's all we give to the agent. Everything else is up to the team of agents to decide where it grabs PDFs, what searches it sends, what inputs and outputs it gives. We just say earthquakes in Indonesia to this guy here, to the earthquake report agent, and hopefully it should build from there. So I'll leave that at its own cell. Okay, and then we set it up just like before. Response generator master equals runner. Oh, underscore master dot run. Oh, did I miss a step? I've missed a step, haven't I? Yes, I need to, sorry, I missed this important part where we set the session service master, the in-memory session service. We set the runner, we create the session. So I'll just copy that. There we go. That's basically exactly the same every time. There's probably a better way to set that up. Okay, good. And then, yeah, this, let's do that, copy that. Okay. So there's the runner master.run, content user query. So that's our user query. Let's go. Oh, and we have an error. Great. Session not found. Report 01. Did I run that? Oh, I missed. This is what happens when you copy and paste. I must have missed a oh, what have I done? Session service, session ID report 01. Session not found, report 01. Okay. Well, session ID. Did that do it? Oh, okay, what have I done? So previously, I had my session ID here, session 03. Why isn't it working? Session master port 001. Is this one not working? Session master. It seems to exist. Port 01. No. Session not found, report 01. Interesting. What if I do this? Session ID. I mean, this shouldn't make a difference. Equals report 1. Let me just do that. Session ID. Session ID. Session ID. User ID. Okay. Okay. Oh, is anyone else? Thanks, Eric. Why is it? Is this working for other people? Maybe I should. What else have I messed up? I wonder if. Okay. So what are we doing differently from earlier? I wonder if have we actually just timed out? Same error. Okay, what have we done? We've just missed something. Okay, let's just do this. I'm just going to copy this. That will be our new. That worked. Okay, so now session.
I think I'm getting something to do with a mismatch between the user ID and the session ID.
Oh, yep. Okay. So I'm just trying to sort of clobber this and use one that worked earlier. So I've sort of reset that. Let's see if instead of runner, I'll use the agent runner. So we're deleting our old one. Oops, we'll still call that. Call that session ID, user ID. What was the difference? Session service create. Okay, that worked. I want to find the error though. Await sessions. That was the one that worked. But which one broke? So
for me, the specific line was the user ID equals line.
This one.
Yeah. Instead of doing user ID equals and then defining the string there, I just did user ID equals the user ID variable.
Okay.
It worked. So
Okay.
is it something to do with changing user IDs in the middle of this whole process?
It must be, I think. Good pickup. So there you go for everyone playing at home. Let me can just recopy that, but I will. Okay, the only difference here is I will go user ID equals geo workshop user, and then user ID equals user ID. Let's see if that likes that. Oh yeah, okay. All right. So there's the error, there's the mistake. So this is here we've hard coded geo workshop user. This is referencing user underscore ID, which we defined much earlier, which wasn't geo shop work user. So that's the problem. Yeah. Okay. So just to clarify that, if you just change user ID in this section to user underscore ID, it should work. That's the only change you need to make. Good. Thank you very much for that. Okay, I'll run it again. Cool. All right. And while that's thinking, we can then now my original one, which I didn't copy and paste, which I wrote out, it wasn't getting the archive IDs very well, so mine might not work very well, I think. It should. Here are some key okay, so Indonesia is situated. Here are some key findings. Indonesia experience of substantial, there you go. So it's written this like little literature review, I guess. And recent research has identified that the fault beneath Jakarta, very good, very good. So yeah, it's basically written us a little literature review using our 3 agents. We can see what papers it's kind of used. It hasn't given a reference. Maybe we said reference, write the reference in. It might do that for us. Oh, go ad free. Okay, so that's actually just using any website. It doesn't seem to just be using archive, which is fine. It's also looking up Wikipedia, so I'm not sure when that has occurred, but I think if I fixed my first prompt, it probably would have behaved a little bit more like I was expecting it to. Cool. So it's found a bunch of things. It's written a review, which is more or less what I wanted. So that's good. And I think that's it. So yeah. Okay. How did everyone else go? Any oh yep, good stuff with the backticks. Excellent. Hopefully people are back on board. Yep.
When you mention archive, is that the URL, like it's ARXIV?
Yeah, that's right. Archive.org.
Ah, cool, thanks.
That's a
great reference, Emma.
Chi is the Greek letter. It's not an X.
Oh,
but it is an X. But yeah, I think that
should be sending you some swag, Nathan.
There you go. Yeah, teaching you lots of little details. Cool. Okay, so we now have a full functioning orchestrated agent. So just going back to this guy, which explains it all. We remember all we said. Earthquakes in Indonesia. That's all we gave this thing. Everything else was totally up to the agent, what it did, what tools it used, what PDF extractors it used, whether it actually did that, whether it found details using this. We can drill down into the output to see what tools were called. And actually, I'm not sure, to be honest, I don't think it called the tools that we actually expected. I think it's fine. Probably doing more search than anything, because we didn't get any prints saying tool called. But I think that's because of my very first prompt, which sort of threw everything off. Nevertheless, so that's the nuts and bolts of it. I'm going to go through the literature reviewer agent flow. This is just another agent flow to give you a very general literature review bot that you can just go and use if you like, and you can tell me how accurate it is. So there's lots that we kind of haven't covered today, but they're agents in a nutshell. You've seen how the ADK, the Agent Development Kit, works. And yeah, the syntax behind it, it gets repeated again and again. You set up your agent like that, and then you stick it all together. You stick the tools in, and it's kind of ready to go. But we haven't spoken about something called MCP, Model Context Protocol. This is it's kind of like I guess an API or something. It's a certain protocol for agents to interact with servers and websites. And so if you say, hey, agent, use the MCP for the USGS. I don't know whether they have an MCP, but the USGS might host an MCP that says, hey, if any agents are contacting this site, here's what you do, and here's the content we can provide you. And so that way you can kind of, yeah, standardize how agents interact with different surfaces. I'll talk about that a bit more in the anti-gravity session next week. Also, looking at the evaluation of observability, we sort of read through the raw output, but there's different ways that you can sort of understand what an agent's doing and evaluate how accurate it is. And there's some built-in sort of like protocols to measure the success during the ADK. You can monitor your agents like in real time. But yeah, that's important and everything. And yeah, we can talk about anti-gravity next week, where the agents are kind of built into the platform. Obviously, ethics and responsible AI and humans in the loop, we did touch on that. But yeah, don't trust everything. And I mentioned there's lots of alternatives to the ADK. This is just one sort of Python package. I think probably the industry standard is LangChain, or depends who you ask. But I guess it's kind of the same. You write functions, you give it models, you give it tools, and you give it prompts. And so, and then you invoke the agent in some way. So we use that runner, but there's yeah, different ways to do it. Okay, so finally, or second finally, there's two more things. We can combine a whole bunch of agents together. Let me zoom out, oops, a little bit so I can see this. So if we want to combine some agents to search the web for scientific articles, pass the content from articles to text, and then summarize the draft as a paper introduction, that's kind of what we're doing with the earthquakes, but we can kind of do it in a better, more general way. So you don't have to always learn about earthquakes. You can then pass the output of that to another agent, which will review it and say, oh yeah, this is correct or not correct. And this introduces this concept of sequential agents and loop agents. So firstly, one agent will pass the content of one step to the next, and the final one will sort of loop back and forth until it's happy with its result, and then it will come to the conclusion. Okay, and so for this, we will use our find agent to find archive IDs, which outputs research findings. We then use a reader agent to grab those PDFs and stick them all together and pull the content out, and then a writer agent to use that content in its context to write a draft, and then we give the draft to our supervisor, and our supervisor will read it and critique it and say like, no, you need to give more references or whatever it says, and finally it will get approved. Okay, so this is starting from scratch. You set it up like we did at the start. We import all the items we need. The only extra bits we're importing is agent. We import agent, but we also introduce this thing called a loop agent and a sequential agent. I think agent's kind of general, and loop agent and sequential agents are specific things like that. So I'm going to well, you can just grab. Do we have anything else? Oh yeah, we also use tool context. that's for loop control, okay? I think that just lets you escape the loop if it thinks too much. So I'll just do that. I'm just going to delete that last line because our API key is already defined. All these things are mostly imported already. PyPDF we use again. And all right, so we define a bunch of functions. The exit loop, this is a really simple function. Call this function only when the critique is approved. It signals the workflow to stop. And so that's it. We have this tool context actions escalate. That's what we need. So yeah, we need this specific ADK command to break out of the agent. So it's like having a while loop and setting, false, and you'll escape the loop. So that's a really simple function, but it stops you from spending an infinite amount of tokens. And then we have our PDF getter. So that's very similar to before, a bit more general. It's not just about earthquakes. So it takes a archive ID and creates a PDF or gets a PDF. All right, and then we have our, so I'll copy those functions across. So there's really only, we've only got two functions defined. One's to exit the loop and one is to grab papers. I think we also use Google search as well. Okay, so then we have our PDF finder. So that one, this agent uses Google search and it says, give me the archive identifier specifically. So I'm strict about that. I said, give me the archive identifier. You can make it so the output of these agents are like a JSON format. So you can give it the exact output that it's required. You can try and prompt it. So that's what I've done here. I've said, like, in the prompt, please give me a list, and hopefully it will abide by that. It should abide by that, but you can force that as well. Okay, then we have our agent which reads PDFs, so that's similar to what we had before. And then we have our agent which writes text, and then we have another agent which reviews it, so review the draft. So each time it will get passed, and then we pass this refiner. So okay, and here's an interesting part. We go, did I have that? Anything else? Oh yeah, sorry, I skipped over here. So this first one will find papers, and then here I've got the output key, research _ findings, and then down here in the PDF parser, I then pass that as input. So with this list of archive identifiers, and that's where we use that output key as the input for the next model. So that's, I guess, important. And then we use the output key, paper content, as input into the next model. And then we use the output of the current, and then that outputs the current draft, which I use in the next model, next agent. And then I use the current draft and the critique as input. Good. Okay. Finally, we have, we set up our loop agent. And so the loop agent is a little bit different to what we've seen, but basically you set the name of it and you give it all the list of sub agents, and you can set how many iterations. So you can set that to 2, 3, probably 2 is enough, maybe 3 in this case to review the document. And then we have the sequential agent where we put those 3 independent agents and then the refinement loop, which is a loop agent. So there's like nested agents here, which can be confusing. But when you think about it, what you want to do, the steps you want to take, hopefully the logic becomes clear. Okay. Good. That worked. And then we set it up exactly like we did before. Insert session memory, runner, etc., etc., etc. And okay, there's the query, write an introduction section to a research paper titled. So put your area of research there and see how it goes. I'd love to know the so computational design of meta. Well, I think I just grabbed that. Let's see what's on the front page of Nature today. Okay, explore content, research articles, good. All right, let's see if it can write a good topic on spinal neuromotor rehabilitation using a portable isokinetic training robot. Let's put that in, eh? Okay, I'll run that. And here it goes. Oh, great. Not found code. Oh, Gemini 3 Flash is not. Oh, right. Okay. So Gemini, thank you very much. You just called that out, Javier. So Gemini 3, let's update that to be, I think it's 3.1 Flash now, maybe, or is it Flash Preview? Flash, what's the name of it? We can use, how about Gemini 3? Oh yeah, I think it's Flash Dash Preview. 3 Flash Dash Preview. Let's try again. Did I use another one? 2.5. Okay. Let's try again. Okay. Come on. I was thinking, doing probably lots of iterations. On the report agent, you found another typo. So the report, wait, was that in this section? Reader agent. Oh, that was for the previous one. Okay. Oh, yeah. Okay. Thanks, Thomas. So that's probably why my last one also didn't do a great job. I'll fix that in the notes. Oh no, what's happened now? Unavailable. Ah, okay. It's not good. Let me try again. Let's go. Third time's a charm. Okay, while that's thinking again, so yeah, hopefully that works, and hopefully you can just reuse that code if you like. I mentioned before about Colab being in its own like special asynchronous environment. The code down the bottom is how you basically run this if you're using a script like on your local computer or something, or outside of Colab. The only difference is that you have to wrap everything in an asynchronous function, like your main function. So you do async and then put everything in main, and then when you call the generator, you have to run that. You have to wrap that in an async for loop. Okay, so they're the two things that you kind of have to change, and then you put everything in this async run. So if you read the documentation for the ADK, most of it looks like that because it doesn't assume you're running in Colab. All right, it actually worked. Amazing. So it looks like it grabbed to PDF for at least one. Didn't grab many PDFs, but that's okay. We got one. So let's what's the so if I look at the all content objects, this thing that we've built, you can probably have and see what happened and see if it does some weird stuff sometimes. Okay, the human spine, a complex biomechanical structure, plays a pivotal role in posture, movement, and protection of the spinal cord. All right, cool. So that sounds like an introduction. The advent of robotic technology and rehabilitation has revolutionized. This paper introduces a novel portable isokinetic training robot. I probably should say, yeah, use references. I think it will then use references. Now, is that the... I think that's it. So yeah, so it seems like it's working. If we want the last one, I have to do this. If I want the final output, this is the code for the final output was all content objects -1. So all content objects, I think that type object is not subscriptable. Is it that one? Right. Okay. Content, that one's. Nope. Parts. Is that it? Nope. Content. Okay. I think that's not what I need. Sometimes, yeah. Oh, okay, maybe I'm not on the right one. 0. First one. -2. Is that the last one? Loop exited. -3. Where's my? I want to know where my last -4. The final iteration is. Anyway, if I just do 0, it can give me an idea of what its output. So there we go. You have a literature review, full agentic workflow, which can be hopefully useful for you. So I think that's everything that we can talk about today. Are there any final questions?
Two questions of completely different scales.
Mhm.
So one, we've a couple of times used adjectives like "you're a helpful this" or "you're an expert that." Do you find that there's any difference in performance when using those sorts of adjectives, or is that just historical kind of momentum?
Yeah, I think it's definitely legacy. Like historically, that used to work. Now I find if I prompt like the latest models, like you're an expert researcher, it'd be like, I'm not an expert researcher, I'm an AI model, and it's like, oh, you're too self-aware. So yeah, I don't think that works as well as it used to, or adds any value, I think.
And the second completely opposite end of that spectrum is, have you ever tried using AI code writing to generate an agentic AI cluster like this?
This was definitely supported by AI code writing. I think that's where these original little the emojis came out, and I'm like, oh, I like that, I'll keep that. But it needed a lot of massaging. This gave me sort of like the framework, and I was using the ADK docs, so the documentation in the context to make sure I got it working. So yeah, I think especially for things like that are really like brand new, it struggles with, because it doesn't have the training on it. But yeah, like it's helpful, but definitely not perfect.
Okay, a question about technique. I've got about half a dozen mind maps saved as PDFs. Now, should I just revisit them and just, I don't know, maybe do some sort of weird text export, or is there a way to search through existing agents?
So yeah, the Gemini models are multimodal, and so maybe able to interpret them if you just give it the PDF, or give it the JPEG or whatever it is, and say, this is a mind map, give me the ideas about this, or like what's expressed in this mind map. I think that should work.
Okay.
So
okay, I'll try that. There, I can barely read them as a human, which is why I gave up the research. And I was waiting for this to come along. I
mean, you can also just put them into into the web interface as well, like drag them in and see how it performs in there, as a test before you write the code. But I think the terms of service are different as well. So if they're any data privacy, then don't do that in the web interface. But in the API, the terms of service are different, so they don't use this data anywhere. Yeah.
Last question: would it make sense to try and do this from inside Notebook LM, or that's just completely separate?
Yeah. So okay. They released a whole bunch of new updates for Notebook LM, and I haven't had a chance to look at them. But generally, I think the answer is no. So you might, for your problem, Notebook LM could be a great option for that. You put all your documents in there, and then it can you can interpret it. But if you're trying to build like agents, then probably not. Because it doesn't write code, I guess, as well. And,
I'll probably just do it as a two-pronged attack.
Yep.
Cool. Thank you.
Good stuff.
And you get an elephant stamp because you persevered and you crowdsourced the solution.
I love it. That's why you guys are here. Alrighty. Thanks. Okay, there's one final question. What production frameworks do you recommend for benchmarking and evaluating? So the ADK has built in, I haven't heard of Raggers or TrueLens. So I don't know the exact answer to that. But yeah, I think in science, it's not so important, to be honest. In production frameworks where people want the results to be, less experimental, then you really need to set your evals and all that kind of thing. But science, which is a bit more exploratory. However, if you need reproducibility, then you probably need certain level of grounding and benchmarking, I guess.
Last question. Is
Mhm.
there something like Lighthouse that we can run all this stuff through?
What's Lighthouse?
Okay, Lighthouse was originally built to scan a website and work out where the efficiencies were and if it met the UX standards. And they actually used it in one of the keynotes at Google I/O. They pushed something through Lighthouse.
Right. Okay. Great question. I don't know the answer to that.
Next week.
I reckon that might exist though. I feel like someone would have built this because it sounds like a good thing to do for AI agents.
We've got 7 days to research it.
Okay, let me make a note. I'll leave this up. Okay, good.
Good stuff.
All right. Thanks everyone for persevering, and hopefully that's useful. And I'll speak to you again soon. Farewell.